Hi everyone, welcome to the notes for Unit 2, Day 1 on radian and degree measure. We're going to start today by talking about angles, which hopefully we remember from previous years of math. An angle is a measurement of how much we turn around a point that we call the vertex. Small angles that are less than 90 degrees we call acute. Exactly 90-degree angles are called right. Bigger than 90 but less than 180 are called obtuse. Straight angles are exactly 180 degrees, reflex angles are larger than 180 degrees, and full rotation angles are exactly 360 degrees. So this should all be a review. It's not part of our curriculum, we're just making sure that we go over that vocabulary and that we know it. Two other terms that you might remember are complementary angles. So two angles can be complementary if their measurements add up to a right angle or 90 degrees exactly. They don't necessarily have to be together as long as their measurements together add up to equal 90 degrees, then that makes them complementary. So for example, we can move this around and see that as one angle gets bigger to be complementary with the other angle, it would have to get smaller to stay equal to 90 degrees. That's an example of two complementary angles. And then of course we have supplementary angles, which are very similar, except these angles add up to equal 180 degrees. So an easy way to remember that is the C of complementary stands for corner or a right angle, and the S of supplementary stands for straight, as in a straight line. Okay, we're going to take those concepts that we learned previously and we're going to start applying them now to trig angles. We're going to get to that. Exciting. So I should also mention at this point that at any time during the video, if you come across something that you haven't seen, that you don't remember, or that you are unfamiliar with, you should definitely pause the video and jot this down in your notes. These videos are meant to be references for you to enhance your notebook. So make the notebook as detailed as it needs to be for you. So this year, what we're going to talk about specifically are angles that are graphed on the coordinate plane. So if you remember, the coordinate plane is the x and the y axis. When they crisscross, the intersecting point is called the origin, and it divides into 4 quadrants. Quadrant 1, 2, 3, and 4. We always start with the top right quadrant because that's where all the x's and y's are positive. So it's our most frequently or commonly used quadrant. And then we go counterclockwise from there. So one thing that I want to talk about, we're going to get back to that information in a minute, is an angle that's graphed on the coordinate plane in standard position. It's important that we know this, has its initial side or its starting side along the positive x-axis, and its terminal side could open up anywhere in that coordinate plane. So an angle graphed in standard position on a coordinate plane would have its initial side along the positive x-axis, and its terminal side opens up anywhere within that coordinate plane. So you should also know what the initial side and the terminal side is. It's basically the two arms of your angle. So if we open up in a positive direction, that means the counterclockwise direction, or the same direction that the quadrants turn in, we would have a positive angle. If we start on our initial side, meaning the positive x-axis, and we open in a clockwise direction like this, that would be a negative angle. This is just a review quickly of the quadrants. So again, here we have positive angles start on the positive x-axis and open in a counterclockwise direction, or in other words, the same direction that the quadrants go. And then the negative angles start on the positive x-axis and open in the clockwise direction. So hopefully we remember this. A positive 90-degree angle would open up to the positive y-axis. A 180-degree angle would open up to the negative x-axis, and a 270-degree angle would open up into the negative y-axis, and a 360-degree angle would get us back to where we started from, or would be the same thing as a 0-degree angle. Which brings me to my next point. An angle that is graphed in standard position, meaning its initial side is along the positive x-axis, and ends in the same place is what we call coterminal, meaning their terminal sides look the same. So the angles look the same. They might just open up in a different direction, meaning the positive direction and the negative direction, or they could be rotated more. So a 0-degree angle would be one in which the angle doesn't open up at all from the initial side, and a 360-degree angle is one where it rotates around exactly once and ends in the starting position. So these two angles look the same, but one is 0 degrees and one is 360 degrees. Angles that have the same ending point or terminal side are what we call coterminal. So along those same lines, a positive 90-degree angle that opens in the counterclockwise direction from the positive x-axis is coterminal with a negative 270-degree angle that starts on the positive x-axis and terminates or continues in the negative clockwise direction and ends on the positive y-axis, would be a negative 270-degree angle. So for example, if they wanted us to draw a negative 45-degree angle on the coordinate plane, our initial side is always going to be along the positive x-axis. Because it's a negative angle, we're going to open it in the clockwise direction, and then we're going to end 45 degrees later, which would keep us in quadrant 4, halfway between, because the quadrant's 90 degrees. So it would terminate in quadrant 4, and we draw this little arrow to show the direction that we're opening, that it's a negative angle. The last thing that I want to talk about in terms of angles is what's called a reference angle. A reference angle is an angle that is the shortest angle to get from the terminal side back to either the positive or the negative x-axis. So in this case, with this negative 45-degree angle, the reference angle would be 45 degrees because it's closest to the positive x-axis as opposed to going to the negative x-axis. So if you're in quadrant 1 or 4, your reference angle will go back to the positive x-axis, and if you're in quadrant 2 or 3, your reference angle will go back to the negative x-axis. Reference angles are always positive because it's regardless of direction. It's just the number of degrees, it's the absolute value, or the number of degrees that it takes to get back to the x-axis. So in review of the new information, a standard position angle is graphed on a coordinate plane with its initial side along the positive x-axis and its terminal side is in any one of the other quadrants. An angle that opens in the counterclockwise direction is a positive angle. An angle that opens in the negative direction, in the clockwise direction is a negative angle. Coterminal angles are angles that share a terminal side. For example, 120 degrees and negative 240 degrees have the same initial and terminal side. That makes them coterminal angles. They just open in opposite directions. So a coterminal angle could open in opposite directions, or it could be rotated more or less. So if you think about it, an angle that opens to 120 degrees would be exactly the same as an angle that opens 480 degrees, because that would be a complete turn plus the 120 degrees to get it back to this position. And a reference angle is an angle that's drawn to the positive or negative x-axis. It's always an acute angle because it's the shortest angle to get back to the x-axis. So in this case, in quadrant 1, you're your own reference angle. In quadrant 2, you're getting back to the negative x-axis. In quadrant 3, you're getting back to the negative x-axis. And in quadrant 4, you're completing your turn to the positive x-axis. And our last topic for the day today is radians. A radian is another way to measure an angle besides degrees, and it's what we're going to use a lot in trigonometry. So by definition, a radian is the angle that's made when the radius is wrapped around a circle. So let's show you what I mean by that. So if we take our radius and we wrap it around the circle, it creates this wedge, and the angle of that piece of pi is considered 1 radian. So a radian is another way to measure angles in trigonometry. A radian is equivalent to roughly 57.3 degrees. So if we take our radians and we try to complete around the circle, it takes roughly 3 radians plus a little bit more to get to half the circle. And it actually works out to be exactly pi radians equals 180 degrees. So if we work it out, we can work backwards and figure out that 1 radian must equal about 57.3 degrees. So if you ever need to convert back and forth to go from radians to degrees, multiply by 180 and divide by pi, or in other words, multiply by 180 over pi, or to go the opposite way, multiply by pi and divide by 180, or in other words, multiply by pi over 180. Here are the measurements of common angles that we'll use very frequently this year in math. You don't need to know the approximate decimal of radians. The degrees and the exact radians are the important thing. So if there were approximately pi radians in half a circle, there are 2 pi radians in a full circle. So 1 radian is equal to 2 pi. 1 circle is equal to 2 pi radians. So radians are preferred because they're kind of more pure. They're based on the measurement of a circle. So as we get higher in math, they're going to be preferred over degrees. So that's it. Hopefully we learned a little bit of something from the notes, and next class we'll talk about how we're going to apply all this information to different problems. But the important thing is that we understand what an angle is, that we understand the related vocabulary with angle from previous years, complementary, supplementary, acute, obtuse, all of those. We need to be able to graph angles in standard position, understand what that means, understand the initial side and the terminal side. We need to understand the difference between positive and negative angles. We need to know what a coterminal angle is, what a reference angle is, and now how to measure angles in radians. And if you got that, you're in really good shape. Come into class with any questions, and we're going to go over the problems and practice.